Okay, so we've got some mixed HSC questions here on APs. Okay, just a little refresher on APs. We have a common difference, so subsequent terms have the same difference between them. And so we're either adding or subtracting to get to the next term, as opposed to a GP where we are multiplying by some constant term. Okay, so J is making a pattern using triangular tiles. The pattern has 3 in the first row, 5 in the next, and 2 more in each subsequent row, or each successive row. So let's get a few things down here. Our first term is A, so that will be 3. Our next term would be 5, and then 7, and so on. We could count, we could keep drawing, but the main thing is that our difference is 2. So I would straight up say we want to generate an equation for Tn. Okay, so that's A plus n minus 1 D. Now, so just straight away substituting into this, we end up with Tn, or the nth term of the series is 3 plus n minus 1 times 2, which comes out to be 3 plus 2n minus 2, or Tn equals 2n minus 1. Okay, so we've got our equation. Now that actually hasn't earned us any marks yet, what it may do in the first part of the question, but it really hasn't answered any of the questions that we've been asked here, but it does set up the basis for the whole question. So for part 1 there, well, how many tiles would J use in the 20th row? Well, that means if n is 20, the tiles, T20, is 2 times 20, 40, minus 1 is 39. Okay, so we can use 39 tiles in that 20th row. Number 2 there, how many tiles would J use to get all together to make the first 20 rows? Okay, well this is a sum question. So sum of the series is, well, there's 2 ways we can do this. All these formulas, by the way, are on the new reference sheet. I think we're going to go n over 2 first plus the last. Now the good thing about this is we have n, well, it's still 20, we have our first term 3, and we have our last term in this part of the series, which is 39. So I'm going to go, the sum there is 20 on 2 outside of 3 plus 39, which is 10 multiplied by 42, which is 420 tiles. Now again, if you'd really like to, and you've got some time on your hands, you could go draw that out and confirm that's correct, but I wouldn't worry. Really, we can add these sort of things up manually if it's sort of 3, 4, 5, maybe even 6 terms, but anything more than that we're going to have to look at a formula. And the last one, J has only 200 tiles. How many complete rows of the pattern can J make? Well, again, this is going to be a sum question. This time the sum of n terms is 200. Now the difference is we don't know what the last term is, so this time I would probably go and use this version of the formula where the sum of n terms is 2a plus n minus 1 d. Now, and of course that's multiplied by the number of terms on 2. Okay, so let's go and work this out here. Once again, we know that a was 3 and we're adding 2 each time. We don't know what n is this time, but we do know the sum of it is 200. So what I'll end up with is 2 times 3 is 6 plus n minus 1 times 2 outside of still n on 2 equals 200. Needs a little bit of neatening up here. So I'm going to end up with 6 plus 2n minus 2 outside of n on 2 equals 200. And I'm going to end up with 2n plus 4 outside of n equals 400. Now what I've chosen to do there is multiply both sides of the equation by 2, which neutralizes that half. And at the same time I've just gathered like terms in here, and I'm still left with this n multiplying the whole set of brackets. Now what we'll end up with is 2n squared plus 4n minus 400 equals 0. I'm going to go and halve that all straight away. So I'll end up with n squared plus 2n minus 200 equals 0. And I can't see a way to factorise that really quickly, so I'm going to go to the quadratic formula where n equals minus 2 plus or minus the root of 4 minus 4 times minus 200 on 2. And what we end up with is minus 2 plus or minus the root of 804 over 2. Now we're going to need a calculator for this. And what I'm going to do here is say that we end up with one solution, which is 13.17. Now we do have another solution there. If this solution that I've written here is minus 2 plus the root of 804 on 2. Now obviously if we go and subtract that, we'll end up with a negative answer, because minus 2 minus it's 20 something is clearly going to give me a negative answer. Well, that's not going to work for us, so n has to be positive. So we need to ignore that negative solution. We go and say n is greater than 0. Now n must also be an integer, so what that means is the 13th row of this pattern uses just less than 200, and the 14th row will require me to use more than 400, so therefore I can make 13 complete rows. Now it wouldn't matter if our answer there was 13.99. Let's say we were one tile short of being able to make the 14th row. We're still one tile short and we could only make 13 complete rows. So our answer here is 13. Let's look at our next one here. A skyscraper of 110 floors is to be built. The first floor to be built will cost $3 million. The cost of building each subsequent floor will be $500,000 more than the floor immediately below it. Okay, so our first, again, we've got an AP here because we're going up by $500,000 each time. So floor 1, okay, we'll use Roman numerals. Floor 1 is going to be 3 million. Floor 2 is going to be 3.5 million, and so on. We could go set that up. Now that means my first term is 3 and my difference is 0.5. Okay, what will the cost be of building the 25th floor? Well, I think we're going to need our formula here. So Tn, the nth term of the series is A plus n minus 1 d, which is 0.5, which if we go and neaten that up, it's plus 0.5n, could write n on 2, minus 0.5, so ends up being 0.5n plus 2.5. Now all those are in millions of dollars. I think it's just easier to write it that way. You could write n on 2 and 5 on 2 there. Now of course we need to go let n equals 25. So the 25th term will be 0.5 times 25 plus our $2.5 million base, if you'd like. And what we end up with is 12.5 plus 2.5, which is $15 million. Okay, that's the cost to build the 25th floor. Just the 25th floor alone. And it really, you could, again, this sort of question, it will take you a lot of time, and I wouldn't suggest it in an exam because it will just waste time. But what you could do is go and say, first one will be 3, then 3.5, 4, 4.5, and so on, and just add them all up. Ill-advised for an exam, but you could check your answer that way if you're just practicing or would like to confirm these formulas do actually work. Part 2 here, what will the cost of building all 110 floors of the skyscraper be? Couple of different ways we could do this. This is a sum question. What will the cost be of building all the floors? It's a sum question. So I would suggest we go and use the sum of n terms is n over 2, first and the last. You could do it the other way, 2a plus n minus 1d. This is just my preference. If you would like to do it the other way, it will come out with the same answer. I would go and say that the 110th term, or the cost to build just the 110th floor, is going to be 0.5 times 110 plus our $2.5 million base. Okay, so what that ends up being is 55 plus 2.5, $57.5 million. So that means the sum of 110 floors is our 110 on 2. 57.5 is our last, plus our first is 2.5. I'm sorry, that's 3 actually. That first term is indeed 3. So it's 55 times 60.5, which comes out to be, it's going to be a whole lot of money to build 110 floor apartment building. It is $3,327.5 million. Now you could write that all out without this decimal here, but the main thing is that you have the correct numeric answer. Okay, one more here. Susanna is training for a fun run by running every week for 26 weeks. She runs 1K in the first week, then runs 750 more than the previous week until she reaches 10Ks in a week. Once she reaches 10Ks, she's going to then continue to run 10Ks each week. Alright, so our first term is 1. Our difference is 0.75. Doesn't matter if you go meters or kilometers, just do the same. Don't have the first term as 1 and then the difference is 750. That'll give you the wrong answer. That's saying she's running 1 kilometer in the first week and then 750 kilometers in the second week. So let's get our formula here. Tn equals 1 plus n minus 1 times 3/4, 0.75. We end up with 0.75 n plus 0.25. Okay, could have those as fractions as well. So therefore T9 is going to be 3 on 4 times 9 plus 1/4. So I've got this wrong here. That should be a 4. And that ends up being 7 kilometers. So in the ninth week, she runs 7 kilometers. In which week does she first run 10 kilometers? So we want to go work out where t to the n equals 10. So therefore we're going to go and say 75 n plus 0.25 equals 10. And that means that 0.75 n equals 9.75 and n equals 13 weeks. Okay, or the 13th week. Okay, it's the 13th week in which she runs that 10 kilometers, and then obviously week 14 she's going to run 10 kilometers. Week 15 she'll run 10 kilometers, and so on and so forth. So what is the total distance she's run? Well, it's going to be a sum, but it's a little bit of a different sum here. So what we're going to have is Sn equals, well, it's only an AP for the first 13 weeks. After that there's no difference. So what we go and say is it's the sum of the first 13 weeks plus the first and the last. So that'll be 11 times 6.5, which is 71.5 kilometers. But then also we've got to remember that she then goes for week 14, 15, 16 and so on for another 13 weeks running 10 kilometers a week. So it's 10 lots of 13 or 13 lots of 10 there. So we have to add another 130 kilometers. So that means in the 26 weeks she has run 201.5 kilometers. Okay, so really you can treat the first 13 weeks as an AP, and then the next 13 weeks she just goes and runs 10 kilometers a week. So that's 130 kilometers.